What is my AMC Sunday? Akshaj.
Yes, sir.
Yeah, it's showing up as 8. Okay, that's short form. Okay. Why is there a lot of echo? Is it from your side? Okay, now it's better. Are you able to hear me well though, Akshaj? Ashi, you're okay? I'm hearing a bit of echo. Rachit, can you unmute for a second?
Yes, sir.
Okay, you're okay, right? So definitely something on the Akshaj's side, because when he was speaking, there was a bit of an echo. Okay, all right. So let's get started. Any questions from last class? Akrit, Jan, Neve, Shorab, I need to see the videos, please. I need to see your faces, please. So turn on the video. What did we do last class towards the end, Akrit? Can you recap for class?
So in the beginning, like you were explaining us in a cyclic or quadrilateral.
Yeah.
So like why the opposite angles are 180. Then you showed us like in a circle, if there are two chords and the triangles are formed, then those two triangles are similar. Then in the then we did a quiz on the quadrilateral hierarchy.
Yeah. And that's where we stopped.
So I don't remember exactly where we ended.
Okay, that's fine. So going forward, I'm going to just randomly call out any ones. Thanks, Akrit. I think that was a good recap. To recap, I'm going to call out randomly someone. I won't say who that will be, so that all of you will stay prepared. To summarize what was done last class, where did we last finish, Karke? So did we do this this question I'm sharing on screen right now? Did we do this one?
So now I remember we finished with 2 questions.
Okay.
Like not this one, but
No, sir.
Not this. Okay. All right. Let's start with this question. Are you able to see this well, right? So you have an isosceles triangle, and the base is 16 and the height is 15. I'm just reading this question in case it's very small font. The diameter of the semicircle is contained in the base of the triangle, as you can see. Right? So what is the radius of the semicircle? Can you guys think for a few minutes and try to solve this? It's actually one of the questions that came up in the other batch. So I thought I'll discuss it here as well. Snigdha, why am I not seeing you better?
I'm facing some kind of problem. It's not giving me the option to turn on my camera. I'll figure it out.
Okay. And Saurabh, I didn't understand the joke. You said you're sorry because you reminded the class was 1.5 hours. Is it that bad? People are looking at it as like a punishment. Yeah, that was a typo actually, but yes, good that you did that. But your comment was funny. You said, sorry, guys, you have to go through half an hour more of torture. Okay, yeah, try this one, guys. If anyone wants a hint, I can give you to start with. In fact, I'll ask anyone, where do we, yeah, I can see you still now. Yeah, good. Where do we start from? Anyone? Any idea? Yeah, Akrit, go ahead.
so you can draw the height, and because it's isosceles, you can divide the base into 8 and 8. And then you can, it's a right angle triangle, so you can get 17 for the...
Yeah, yeah, let me actually paste a bigger diagram so that it's easy to see. Is the size any better? Slightly better, right? Slightly bigger, right? Okay. All right. So what he's saying is, so he's saying we'll drop a perpendicular from here to here. In fact, we'll do it in parts like this. I'll take everyone's contributions. So isosceles triangle, first thing is look for symmetry and all this. So this is ABC. Now the base is 16. Therefore, we have 8 and 8. Okay, Ashi, what can we do now? Height is given as 15.
Yeah, so and we know that that is bisected. So 8, and even after that, so we know that 8 becomes the radius of the circle, right?
Yeah, 8 is the radius of the circle, yes. But what is the hypotenuse? The Pythagorean triplet that 8 and 15 are part of. What is what the hypotenuse AC should be?
220.
Sir, how is 8 the radius of the circle? Like 8 is just that, like what is
No, the isosceles triangle base is 16, which
yeah,
means
but
here to here is 16, right?
yeah, sir, but like 8 is just a region on the right, but that little part which is
Yeah, 8 is from here all the way to, I'm not saying 8 is the radius of the circle. I'm saying 8 is this.
Yeah, no, because Ashi said that, so I got a bit confused.
Ashi said what?
Ashi said that 8 was the radius of the circle.
No, did she?
Yeah.
Semicircle, that's what I said. It
Oh, no. Okay, maybe did I agree with that? I'm sorry. No. Obviously, the radius of the semicircle is slightly smaller than 8. 8 is all the way from, let's mark this point as D.
but confused because the question said that it is contained in the base of the triangle.
Yeah, contained meaning it's lying on the base, right? So it's contained means it's smaller than the container, right? The contained is smaller than the container. So you can think BC, the base is the container, and the diameter is contained within it. It's smaller than that. Does it make sense, Ashi?
Yes.
Okay.
So the side will become 17 and the
Yeah. So 8:15, you should not even think. The 5 seconds that you or 10 seconds that you spent is 10 seconds lost. 8:15, immediately you should say this is 17. Okay. All right. What next?
then the radius of the sun.
Radius be what's louder, Rashi? Okay. Neve, any idea from here? Where do we proceed?
So I
Okay.
found it a bit.
Go ahead, Neve.
No, sir. Can I
That's
just have
fine.
like 1 more minute?
Sure. I'll give you guys 1 more minute, but one important hint. You guys should automatically do this going forward. Whenever there's a circle and there's a tangent, right? You have you see the tangent AC, right? With the circle at the center D. So D is the center. So always draw from the center to the tangent point, a line. So in this case, let me just draw this. Why? Because this, is 90 degree. The tangent and radius are at 90 degrees. And that'll open up new avenues. So this is 90. This is also obviously 90. Right? Because it's tangential. Okay, now can you guys proceed? And this is the radius R that I'm seeking. Let's say this is the radius R, which is obviously smaller than 8. So slightly smaller than 8. The diagram is reasonably drawn to scale. So if you get an answer as 4 or something, 4.2, let's say, you should suspect because it's almost close to 8. If you get an answer slightly more than 8, then also you should suspect. So when you get your final answer, do some basic sense check like this. Yeah? Ashi is smiling, all okay? How do you proceed from here, anyone?
So I'm guessing you find the area of the triangle. I'm not sure if it will help or no, but if I was doing it and if I didn't know what to do, I would have gone with finding the area.
Actually, I didn't even think about it, but that's a wonderful suggestion. Yes, you are on the right track. Go ahead. Area is the keyword, but what area, all that you have to figure out. Yes, thanks, Arnav. You opened up another way to do this. Actually, I was thinking something else, but what you have is another good one. So I want to discuss at least 3 different ways of doing it, including what Arnav just suggested, area. Okay, Snigdha, what is the area of ADC? What is the area of ADC, Snigdha?
So it's 15 into 8, which is 120.
Half into 15 into 8, right? ADC,
Oh yeah,
not
sorry,
ABC.
60.
Half, yeah, but I want ADC, which is the right side part. Half into 8 into 15. The entire ABC would be half into 16 into 15. The right portion, ADC, which is this triangle, like this one. right? That's half into 8 into 15. Yeah, Akshaj, continue.
I got the answer 7.05.
Okay, you can tell it in fractions, please.
Um, 7 120 by 17.
Exactly. Yes. And how did he proceed from here, Akshaj?
From this stage, so since the tangent is what we're trying to find, and since we got the area as 60, so um, it's also equal to the half into r into 17.
Brilliant. Exactly. Right? So this area is also half into r into 17. So if you look at it from the top with this as the base, then it's half into 8 into 15. But if you look at it with AC as the base, this becomes the base. Then half into the height, which is r into 17. And that's it. From here, I can cancel off the half. 120 by 17 matter khatam. Right? Which is exactly like what you said.
I didn't understand.
I'm going to ask Rachit to explain this. Rachit, did you understand? Can you explain?
Oh, no, sir. Even I had some doubts.
Okay, Gyan, can you explain?
Yes, sir.
Yes, go ahead.
So if you take BC is the base and then you find the area, you get 8 into 15, which is 120. Which is half into 8 into 15, which is 60. But if you flip the triangle and you take AC as the base, then like the R will be the height. So you get half into R into 17. And then when you cancel everything out and you equate, you get 120 upon 17.
Is there any better, Snigdha?
Yes.
Sure,
Yes,
right?
sir.
Rachit, does this make sense? Yeah, two different ways of calculating the area. If you keep it this way, DC, which is 8.
So basically, r is taken as the height.
R is the height because it's perpendicular, which is why I always say whenever there's a circle and tangent, first thing you should do is connect the center to that tangential point.
So sorry,
Yes, Arnav.
but I'm not really understanding how you took the R as the height if only part of it is like not it's not fully like touching the triangle except at point E, but at point E the area won't be the same because the triangle is smaller at that point.
Triangle is the same triangle, right? The same triangle ADC, I can look at it this way.
Yeah, no, so I'm not saying that they're not congruent. What I am
No,
saying,
there's only one triangle. Forget congruency. I'm only talking about the triangle ADC here, nothing else.
okay.
Two different ways of looking at the area of this triangle, right? So left side ko completely bhul jao. Just forget this left side. Just focus on the triangle ADC.
Okay.
Okay. So it's something like this, right?
Yeah.
One second. Let me just draw it in another color. Just this portion alone. So I'm focused on this, and this. Okay. So this is my 8. This is my 15. And therefore the area is half into 8 into 15. Agreed? Now, forget the circle also. If I drop a perpendicular from here to here, okay, and I call this as H. Do you agree? The area is half into H into 17 as well. Do you agree? It's the same area, half into 8 into 15. Do you agree, Arnav?
No, sir, because aren't we forgetting about this part over here?
Which part? No, the entire area. Flip your eyes and see if 17 is the base, it will look like this, right? 17 is the base.
Okay.
So it's looking like this, right? 17 is the base. You have your it looks like this. If you flip your eyes, this is how it's going to look like. Oops, I don't know what happened. Sometimes this happens. I'm not able to get rid of this. Gosh. Is this better, Arnav? Or still not okay?
It's still a bit
Okay, I'll do one more time. So this is my 17.
confusing.
This is my 15.
Yeah.
Do you agree? I've just tilted the
Yeah.
diagram. That's all I've done so far.
Just tilted it.
Okay, and this is my height. This is my h.
Yeah.
Now, what I called ADC is my same ADC, right? This is my A, this is my D, and this is my C, and this is my E. This is my E.
Correct.
Yeah, so area of the triangle ADC is half into 17 into height, right?
Yeah.
Which triangle? The small triangle that you showed, this triangle, is
Yeah.
half into this base into height.
Yeah.
And the other medium triangle here, this triangle, is half into this into height. But the collection of the two is half into 17 into height.
Yeah. Correct.
And that's what I'm equating. Half into 17 into height is half into 8 into 15.
Oh, okay. No. Oh, okay. Now I got it. Okay. Yeah,
Understood, right?
Yeah, this makes sense now. Okay, cool.
Okay. So that's one way to do it. All of you, okay? Akrit, you also had something to say, or same thing? You wanted to explain the same thing, right? Okay. Now, obviously, this is the easiest way. I want you to know a few other things also which might come in handy. So one is similarity of triangles, right? First of all, we'll come back to this picture. What is similarity? Just like congruency. Did we do similarity last class, Akshaj?
Yes,
No.
sir.
Okay. Okay, I'll give it to someone else. Saurabh, what are similar triangles? Saurabh.
I'm not sure.
Okay, Snigdha, do you remember or do you know?
So they have the same shape, but not the same size. Which
Yeah, not
basically means
necessarily
that
the same size. Yeah,
not necessarily the same size, which basically means that their angles are equal.
exactly. Right. So if you have a triangle like this, like a big triangle, right? And with the same shape, if I draw a small triangle, right? The angles are all still the same, but the size is different, right? Let's say this is 1/3 of this size. So let's say this is 80 degrees, and this is 70 degrees, and this is 30 degrees. Here also it's the same 80 degrees, 70, and 30. So these two triangles are similar. PQR and ABC are similar. So the way you write it is ABC, triangle ABC is similar by putting this sign to PQR. As opposed to if I have the same size and same shape, right? So for example, if I have another one like this, which is exactly same shape and size, XYZ, let's say. Okay, then I will say PQR is congruent. So congruent ke liye I will put an equal sign below this, XYZ. So this is congruent. So same shape and size, whereas this is similar. Okay, so same shape, but not necessarily the same size. So when you have this, as Snigdha was saying, right, whenever the angles are same, you can rest assured that the triangles are similar. Even not just triangles, even for bigger polynomials, right? We have not polynomials, polygons. The angles are in one are proportional to the angles in the other. Angles in one are equal to the angles in the other. The two shapes become equiangular. Okay. But equiangular need not mean equilateral. Both are important for similarity. Sorry, I stand corrected in what I just said. Initially, I said not just for triangles, even for higher polygons, like quadrilaterals and pentagons and all that. If the angles are same, the objects are similar. Not necessarily the case. For a very simple example would be, let's say I have a let's say not a rhombus. Let's say I have a rectangle. Okay, I have a rectangle like this. You know, all the angles are 90, 90, 90, 90. So let's say this is 8 centimeters and this is 5 centimeters. This is a rectangle. I have another rectangle which is long like this. Let's say this is 23 centimeters and this is 2 centimeters. All the angles here match the angles in the, in fact, all the angles are 90. But this doesn't mean these two are the same shape. They're not the same shape. Right? So equiangular does not imply equilateral. Equilateral means the sides have to also match. Equiangular means the angles match. Okay. Only in the case of quadrilaterals, equiangular and equilateral, well, only in the case of triangles, equiangular and equilateral mean the same thing. Okay. Anyway, back to triangles now. Let's focus on the triangles. So because these two shapes, the blue and the red, are similar, we can talk about something called a scale factor. Scale factor. So scale factor is, it can go either way, either big to small or small to big. So let's say roughly, I'm saying this is 3:1 in this picture, meaning let's say this is 24 centimeters. This will be 8 centimeters. Okay. And let's say this is, I don't know, 9 centimeters. Then this will be 3 centimeters. Or maybe this looks a little more than 9. Maybe this is 15 centimeters. So there'll be 1/3 of 15, which will be 5 centimeters. Okay, and likewise, I'll make up some number here. Let's say this is 21 centimeters. This will be 7 centimeters. So the ratio 15:5 is the same ratio as 21:7, is the same ratio as 24:8. That ratio is called the scale factor, which is 3:1. Does it make sense? Okay. Now, if you compare the ratio of the areas, right? If I compare the ratio of the areas, what do you think the ratio of the two areas would be, Jan? The blue area to the red area would be what?
9:1.
9:1. Why so?
So, because I squared both sides.
But okay, but why are you squaring both sides? No, you're right. You're right. I just wanted to understand the intuition.
But I don't exactly have a reason why.
Okay,
It's
that's good.
just
That's
the
good.
first
Akarit,
thing that came.
your hand was up. Yeah.
So because then it over here it becomes centimeter squared and over there it becomes centimeter squared. We are talking about area. So then
Yeah.
even the ratio will become like squared, right? Because if you are squaring the sides, because you're multiplying one side by another like that to get like an area. So
Yeah.
then even the this, because the ratio between the sides are 3:1, but you're multiplying two sides into each other. So then the ratio of the area will be 9:1.
But you're multiplying two sides only for 90-degree angles, right? So in this case, no angle is 90. It's 80, 70, and 30.
They're similar, right? So the height is also going to be similar.
Exactly. That was exactly the point I was looking for. The heights are also in the same ratio. Let's say this is the height here, and let's say this is the height here. Okay. So let's say this height happens to be 12 centimeters. Then this height will be exactly 1/3 of that, which is 4 centimeters. The same 3:1 ratio will continue in all equivalent measures. So height here corresponds to, is equivalent to the height there, correspondence, right? So the area of this one will be half into base into height. Here it will be half into base into height. I don't need to know the numerical value of any of them. In this case, I've given an example. But as long as you know the scale factor is 3, every one of them will get cancelled as a 3 and a 3. Right? And the half will also get cancelled. So it will be essentially the ratio, the scale factor whole square. So ratio of areas would be the scale factor square. Does it make sense? So when I have similar objects and if I'm just comparing ratios, I don't need any absolute value measurements for any of the sides, nothing. If I'm looking only at ratio, I can quickly tell that using scale factor. Okay, so now that was a similar triangles. Now, if I have a right angle triangle, that brings a lot of similarity if I drop a perpendicular. So let me just draw a picture and then explain. All of you understood, right? The ratio of the areas is scale factor square. And by the way, ratio of volumes, if you are talking about 3-dimensional object, the ratio of the volumes will be the scale factor whole cube. So for example, if I have a big dad here and a small little his kid, his son here, right? So let's say this guy measures, I don't know, 6 foot, right? And this guy, the guy is 3 foot. So the scale factor is 2:1 in this case. Lengthwise, it's 2:1. And if you measure the facial area of this guy to the facial area of the kid, so lengthwise, it's 2:1. Area-wise, it'll be 2 square is to 1, right? Or rather 2:1 whole square. So 2:1 whole square, which is 4:1. So if you count, if you do the face area versus the face area of the kid, it'll be 4:1. And let's say you're looking at what is the ratio of the two mass of the dad versus the mass of the kid. Mass is proportional to volume, right? Because you can say that human density is all the same, whether it's a kid or an adult, the human body has a certain density. So comparing mass is equivalent to comparing volumes, right? So if you compare the mass of the kid, mass of the dad to the mass of the kid, it will be 2:1 whole cube, which is 8:1. So seems a little on the higher side here, but you can just imagine this guy is 80 kg and this little kid is 10 kg, something like that. Although it's not directly a good live example, but you get the idea.
So why do you take cube?
Because it's third dimension, volume. So mass is nothing but proportional to volume, right?
Yeah.
If you're comparing the mass of the dad versus the mass of the kid, it's effectively comparing the volume of the dad to the volume of the kid. And that's length cube. It's centimeter cube or meter cubed, right? Whenever we write a volume.
Okay. Yes. Yes.
Okay, makes sense? Suppose 8:1. Okay, so if I have a right angle triangle here, let me just draw a right angle triangle here. I'll draw it this way. The right angle will be shown this way here. The upar wala is the 90 degree. Okay, so this is my 90. And if I drop a perpendicular from here to the base, okay, let me label all of them. So I'll say this triangle is A, B, C. Okay, and this point is D. And this is also perpendicular. Now there are 3 triangles here. Okay, there is small triangle. So I'll just say triangles. Okay, so the small, which is the ABD. And then there's a medium triangle, which is ADC. And then there's the original big triangle, which is ABC. So this is my ABC. This is my ABD. And this is my medium, which is ADC. All of you can see these 3 triangles. Now, all the angles in the 3 triangles correspond to each other. What do I mean by that? So let's say this angle is theta. Okay. Then in the big triangle, because the upper angle is 90, this becomes 90 minus theta. Agreed? Now, if you look at the small triangle, this is 90 minus theta. Therefore, this is theta. And because this whole angle is 90, this has to be 90 minus theta. So all the 3 triangles have angles as theta, 90 minus theta, and 90. Okay. So all of those triangles are by AAA property, angle property. All the 3 triangles are similar to each other. You with me, Saurabh? You're with me? Neev, you're okay? Okay. Now, let me start writing the corresponding sides opposite to these angles in each triangle. So I'm going to call out names. Okay. Let's see. Neev, we are starting with, right? What is in the small triangle? So there are 9 values to be filled here. This, and this. Okay. So, Neev, I'm starting with you. In the small triangle, what is the side opposite to theta?
So the 90.
Which one?
The 90 degree one.
No, I'll fill one for you so that all of you are clear. So I'm saying it's BD. In the small triangle, which is ABD,
Okay.
the side which is
Okay.
opposite to theta is BD. Does it make sense?
Oh, like that. Okay, yeah.
Okay, so Neve, I'm going to not ask you the next one. I'm going to ask you to fill this guy. In the big triangle, the angle opposite to 90 minus theta is what?
DC?
Which one? BC or DC? Sorry.
DC.
In the big triangle? In the big triangle, DC is
No,
not
no,
even.
the BC. The BC, yeah.
But BC is opposite to which one in the big triangle? Big triangle is which one? The original big triangle, ABC, right? Focus on the big triangle.
Yeah.
Focus on the angle which is 90 minus theta there, and tell me what's the opposite side.
So 1 second, I have a doubt.
Yes.
For ABD small, for theta, shouldn't it be AD, not BD?
No, theta is upper, no? For in the triangle ABD,
Oh,
theta
sorry,
is.
sorry. I was thinking about the medium. I was looking at the medium and thinking about the small. My bad.
Okay. Okay, who was answering this? Neve, are you okay to answer, or do you want to pass?
So I'll pass it on.
Okay, let's say Snigdha. Yeah.
So it will be AC, right?
AC, right? I'm focusing on the Neve. I'm looking at the big triangle ABC, right? In the ABC triangle, 90 minus theta is here. So the one opposite to that is AC. Does it make sense, Neve?
Oh, yeah, yes.
Pakana? Okay, I'll come back to you definitely, just to be sure. So this is AC. So next one is going to be, no one needs to raise their hand. I'll make sure everyone gets a chance. Saurabh, you're going to take this guy.
Yes. So AC.
AC, yes. In the medium triangle, which is ADC, the side opposite to 90, which is the hypotenuse, is indeed AC. Well done. Okay. Akshaj, you tell me this one.
So it will be AB.
Yeah, in the big triangle ABC, the side opposite to theta is AB. Ashi? Oh, Ashi is missing today, right? Jan?
Correct. Sana is not here.
Oh, Ashi is here. Sorry. Who is Sana is absent? Okay, Ashi. Yeah, this one. The small one opposite to 90.
AB.
AB. Yeah. Okay. Gyan. This one.
D.
Sorry, say that again.
D.
I'm not able to hear you better.
So AD.
AD. Okay. The one opposite to theta is indeed AD. Yeah, AD. Okay. Rachit. This one.
So 90 minus theta.
Yeah, the one
AD?
opposite to 90. In the small one, it's AD.
AD.
Yeah, correct. Okay. Saurabh. Saurabh, I just answered. I'll give it to
Yes.
Akshaj.
So the 90 degrees for the big one, right?
Yeah.
So it'll be BC.
BC. Okay. And then last one, I'm going to come back to Neve. This one, Neve, the only one left.
The DC?
Yes, DC. Okay. So this exercise proves that your guys are able to find out corresponding sides in any similar triangles, right? Now, once you do this, it helps write out any ratio, right? So there are three similar triangles here. So I can say, for example, I'm comparing the small triangle versus the medium triangle. And I can compare the small triangle and the medium triangle, and I'm comparing the small side and the large side, let's say, right? This is the largest, this is the smallest side. So angles are also in the same ascending order as the sides in length. So this is the smallest, and this is the largest. This is the hypotenuse, right? This is hypo. Therefore, this is the largest. Right? In the way I have drawn in this triangle, theta is smaller than 90 minus theta, and therefore this is medium and side length. These are side lengths. So side lengths are in this order. So suppose I compare the small triangle and the medium triangle, and I want to compare the small side versus the largest side. So I can write BD upon AB is AD upon AC. Okay. So like that, I can write out whatever ratio I want. Just one of the, so I can compare any two triangles and any two sides in those two triangles and write out the ratio. Okay, so this also helps. Now, how does this help in doing this problem? The problem that we first started to take a look. So let's go over. So this one, okay. Again, let's focus on, it's essentially same as what the area thing is telling you only, but if you didn't want to do it using the area, right? Let's focus on the bottom portion here, right? This one. In fact, I'll lower it so that you're focused only on this one. And I'll erase this area thing here. So it's exactly same thing. You have a right angle triangle ADC, and then I have a perpendicular here. Okay. And I have the height, which is D. I have these measurements here. Okay. Now I know that three triangles here. The big triangle here is ADC. The big triangle is ADC. And the medium triangle is ADE. And the small triangle is DEC. Okay. And then here also you have corresponding, let's say this is my theta, and this is my 90 minus theta. Okay, I'll just call it 90 minus theta. It's too much to write here. 90 minus theta. Okay, and therefore you'll have this as theta, and this will be 90 minus theta as well. Okay, so by the same logic, let's try to use similarity of triangles and connect this. So I will say in the small triangle, okay, in the small triangle, 8 is the largest side, 8 being this is the DC is the largest side, and DE, the height, which is the medium side. H upon DC is nothing but your medium side upon the largest side. Agreed? Is the hypotenuse. Do you agree? Ashi, do you agree?
Yeah, yeah.
Okay. Ashi, can you help me complete? What will this ratio be equal to as far as the big triangle is concerned?
Big triangle.
Which will be the medium side and which will be the large side?
The 15 will be the medium side, 17 will be the large side.
Exactly. So 15 by 17 is this, and DC also I know H by DC. DC is what? 8. And that's it. H by 8 equal to 15 by 17. Cross multiply, H is 120 by 17, which is exactly the same answer that we got. And this is exactly what was happening in the area also. If I do the cross multiplication, what am I saying? I'm saying H into 17 is 8 into 15. If I multiply both sides by another half, it becomes the area. Half into H into 17 was the area. Half into 8 into 15 was the area. So they're all related concepts. Does it make sense?
So why did we do H upon 8? It's a ratio, that's all.
Sort what is your question? Why did we do H upon 8 instead of?
No, sir. Is it because H to 8, it's a ratio, or you've written H upon 8?
Yeah, H upon 8, because I want to bring the connection between the small triangle and the big. In the big triangle, all the three sides are known as 8, 15, and 17. Yeah. In the small triangle, I know one side as 8. I don't know the other side, which is H. I don't know the third side also, which is EC. Okay. So I'm trying to bring a connection between H and 8. How are they related? H is to 8 in the medium triangle. So if I focus on this medium triangle, this triangle, H is the medium side, 8 is the largest side, which is the hypotenuse.
Okay.
Right? In the smallest triangle, which is DEC, H is the medium side, and DC, which is the hypotenuse. H is to 8. If I look at that ratio, I compare with in the big triangle, all the three sides are known. 15 by 17. I'll use that and just compare. Does it make sense?
Yes.
Pakka,
Yes,
na,
sir.
Saurabh?
Yeah.
Another way to look at the same thing, let me focus on the medium side, a medium triangle, instead of the small triangle. Because there also H is known and 15 is H is unknown, 15 is known. So H is what? H is the smallest in that case, right? So H is the, I'm looking at the medium triangle, H is the smallest, and 15 is the largest. Do you agree?
Yeah.
Okay, now I can compare that with the large triangle where 8 is the smallest and 17 is the largest.
Yeah.
Then also it's the same thing. Again, if I cross multiply, I give H equal to 120 by 17. Are both methods clear? Here, H upon 15 is 8 upon 17. Here, H upon 8 is 15 upon 17 for two different reasons. I mean, two same reasons, but taking different forms. Is everyone completely clear on this? It's extremely important, guys.
Yes.
Arnav, you're completely with me?
Yes, sir. It makes like I'm understanding it.
Understanding it, Pakka? Okay.
Yes, sir. Yes,
So
sir.
can you repeat it one more time?
I will not repeat it. I will ask.
So I can explain it.
Okay, go ahead, Arnav. Go, explain. Yeah, explain
So-
clearly and slowly. Okay.
Yeah.
Neve must get it. That's the goal. You're
Okay.
not explaining to me. You're explaining to Neve.
So did you understand what sir had explained about the ratio of one side to another? Like the exercise we had done before, the theta and the theta minus 91?
Yeah.
Yeah, okay. So in this
Oh,
same
sorry,
way,
one second. Let me draw a fresh diagram so that it's clear, right? So I'll draw a fresh diagram and then you can take it from there. Okay, so I'll just draw because it's too much clutter there. So this was, I'll draw a big diagram. Okay, so this was 15. This is 15. This entire thing was 17, all the way from there to here. Okay, and this was 8. And then there was a perpendicular from here to here, which is what we need the measurement of this one, right? Okay, all right. Let me also label it, and then I'll give it to you. So this is A, this is B, this is C, this is D. Okay, over to you.
so over here, let's take the ratio of the median. So we have three types of triangles over here. The BDC, ABD, and we have ABC. That's clear?
Okay, I'll write it
Yeah.
as you say, BDC, ABD, and ABC. Yeah, okay, continue.
So now if you take the ratio in BDC of the medium side to the hypotenuse, because the hypotenuse is the longest side. So this would be our hypotenuse because it is opposite to the right angle triangle. So this is the longest side. And this would be our medium side because you can clearly see that it's longer than this one. So then our ratio over there would become R divided by 8. Because if we take medium to longest, let's just take medium to longest, and let's just say that's R upon 8.
Okay.
And then in the biggest triangle, like in ABC, let's let's take the medium to the longest side. So our our 90 degrees is over here. So our hypotenuse is here, and this is our longest side. So it's 17. So let's keep our denominator as 17 over here because let's keep the denominator 17 over here. My bad.
I'm also writing it on the side here. Continue. Yeah.
One second. I'm doing something wrong. Give me a sec.
No, 17 is the denominator. I don't
Yeah,
know why you put it
17
in
is
the
the
numerator.
denominator. Yeah, my bad. 17, one sec. My drawing is 17 is our denominator because 17 over here is our longest side. Even here it was the hypotenuse was the longest side. Here the hypotenuse is the longest side, so it's 17. And then we need to get our medium side. So what would our medium side be? This one, AB. And we can see the lengths 8, 15, and 17. So 15 is our second longest side. So we got 15. So we take 15 as our numerator.
Does it make sense, Neve?
Yeah, I understand.
Yeah, very well explained, Arnav. Yeah,
And now we can just cross
multiply and get R.
So 17R is basically equals to 15 into 8.
Yeah, and then solve as 120 by 70.
Yeah, so then you can do R is equals to 120 because 15 into 8 is 120 and divide by this 17.
Okay, all right. Let me ask one question for practice. Same concept only for practice. All okay? Neve, you understood this completely?
Yeah, sir.
Pakana? Okay, all right. So
Yeah.
I'm going to make up a problem. So I'll say, let's see. So this is, actually it should look more reasonable. So I have to draw it a little more label. So this is, okay. I'm giving you measurements. So this is 13. Okay, this is 5. Okay, and then I'm dropping a perpendicular from here to here. Okay, and since we are bored with ABC, let's change the names to something else. So this is perpendicular. Okay, so I'm labeling this as P, Q, R, S. So I want you to find all the missing measurements. Find PQ, find QS, find SR. All of you. And PS. In fractions, all of it in fractions. Don't do decimals. Who was that decimal guy? Akrit. No, not Akrit. Akshaj. No, nothing against decimals. Fraction is better. I'll give you guys 2 minutes to solve this.
So I got the answer.
Okay, I'll call out each person for each one of these choices. Saurabh, you want to take PQ?
So I'm not sure yet.
Okay. All right, fine, no problem. We'll pass. Neve, PQ.
So 12?
12. So can you explain 12, Neve?
So like I did 13 square minus 24.
Exactly. Nothing more than that, Saurabh. Exactly. Very simple. You don't need to know anything. Sir, 5, 12, 13 ka triplet hai bas. You know it's 13, 5. The third missing piece was 12, right? Saurabh?
So I had a question.
Yes.
Oh, yes, if I
So
thought
you're
Go ahead, Neve.
so you are written QS, but isn't QS already like given?
No, sorry. When I say 13, 13 is the entire thing. Okay, it's always little unclear when 13 is all the way from here to here. This is 13.
Oh.
Okay. In fact, that's how you got this as 12, right? Otherwise, if you thought QS was 13, then how would you have figured that PQ is 12 then?
Yeah. No, I got confused first.
Yeah, no, that's fine. So, but good. Thanks for asking that question. It's always a little confusing when I have. Okay. So Saurabh, fairly clear, right? You did not need to learn too much to figure that PQ is 12. Agreed?
Yes.
You'll say sorry to class. I'm just kidding.
Sorry, guys.
No, I'm just totally kidding. Okay, 5, 12, 13. Okay, good. Let's see. Ashi, QS. Or actually, whichever you have solved, it's fine. Among the remaining 3, you want to pick something? Ashi.
I'm a little confused because I took QS to be 13, which means my other one will also be wrong. So give me a minute.
My apologies. I did mean to draw 13, and then afterwards to the end I drew the perpendicular, right? You saw me marking 13. That was the base triangle. Then I marked PS. Okay, my bad. I should have labeled it clearly. I'll pass it on to someone else. Rachit, you're okay to take any one of the remaining 3?
No, sir, I'm still solving for them.
Okay. Okay, Arnav's hand is up. Akshar's hand is up. I want to see. Okay, Gyan. Which one do you want to take? Gyan.
So I got PS as 30 upon 13.
PSS
30 upon 13.
30 upon 13. Okay. Okay. Any okay. Oh, in fact, I'll straight away say, what is 30 upon 13 approximately, Gyan?
Sir, it's 60 upon 13.
Correct. It's double of that. But I know his silly mistake, but I want you guys to catch your own mistakes. So what is 30 upon 13 approximately in decimals? Now I'm asking decimals. Very approximately. Jan.
Like 2.3. 2.3.
Correct. Now I've drawn this. I've drawn this picture reasonably to scale. Correct. The 5 looks like 5. The 12 looks approximately 2.5 times bigger. Do you think it's a reasonably drawn to scale diagram? Do you agree, Jan?
Yes.
You can keep yourself unmuted for a second. I'm going to talk to you for some time. So if you call this is 2.3, does this look in proportion to this 5 that you have?
No, sir.
No, it's okay. It's okay to make mistakes. I'm just pointing out, in this case, it's Gyan. Tomorrow it's someone else, right? I want you guys all to learn the sanity checking business. It's very, very important. And therefore, if you had realized this, you would have checked. Can you find your mistake? It's 60 by 13, as Arnav was telling. Can you tell me what your mistake was? You had the half in one place, but not in the other place. Was it?
I took an extra half.
Extra half, right? So just by area, we can just say, let's say this was my H. Half into H into 13 was half into 12 into 5. Another 2 ways of calculating the area, right? We saw. So half gets cancelled, which is H is 60 by 13. That's using the area. But even using similarity, Akshay, are you talking something? You're on mute. Okay, cool. Okay. So 60 by 13, which is approximately how much, Arnav? What is 60 by 13 approximately?
So a little more than 5.
More than 5, kuch bhi.
So a little less than 5. What am I saying? A little less than 5.
Little less than 5, but little less as in 4.8 or
4.6-ish.
Okay. So 52 is 30 times 4. 65 is, yeah. So 60 is closer to 65. And therefore, yeah, 4.6, 4.6, 4.7. Now this makes sense, right? This being 4.6 approximately or 4.7 is reasonable to scale. Gyan, does it make sense? Okay.
Yes, sir.
So in fact, I'll label this as whatever the actual value that we got was 60 by 30. Okay. Anyone else wants to similarity of triangles to arrive at the same 60 by 13? So we know this is 60 by 13, but Neve, yeah, without using area, using similarity of triangles, tell me how H was 60 by 13. Neve, your hand is up. You're struggling to unmute. Okay.
I don't really know, sir.
Okay, your hand was up, which is why I asked you. Fine, no
No,
problem.
sorry, it was from before.
Okay. No, you cannot say you don't know. In fact, given you're saying this, I'm going to persist with you. Neve, unmute. I want you to explain. You understood the similarity concept that Arnav explained also, right? Last time. Small, big, all that comparison.
Yeah.
Take 2 triangles. Okay. Now, your focus is H. You have to find H, correct? all the three
Yeah.
triangles are there in front of you. And right, some triangles have some information, but some other information is missing. Everything is in front of your eyes. Now, how would you find H using similarity of triangles, Neve? Or, okay, all right,
So
fine.
like,
Go ahead.
so the same way like what Gyan
But
had
tell
done.
me what that same way is.
So like from the smaller triangle,
Yeah.
like the small triangle, you take you don't know the height,
Correct.
take half into height and 13 as the base.
Yeah. But that's the
And
area
then
way. That's using area. That is fine. Using area, you found out. That's okay. But using the similarity concept, this is using area. Okay, using areas, I got this. I want you guys to learn multiple ways of solving the same problem. So using similarity, not volume, but using similarity, this by this equal to this by this, and therefore H is so and so. Okay, listen in one more time, Neve. I'll give it to Akrit. Akrit, similarity. Using similarity, explain, please.
Yes, so RS is the smallest side in the triangle.
Okay, so which triangles, first of all, are you comparing?
Yes,
The small and the
yeah, the smallest triangle.
the
So
smallest triangle and the
largest triangle.
largest triangle. So smallest and largest you're comparing. Okay, all right.
So SR is the smallest side. That's what we want to find, right? Yeah. So that upon the largest side is 5. So just call that what? RS upon 5. So
Okay.
now RS, now the largest triangle, in that the smallest side, is 5 and the largest side is 13. So it's 5 upon 13. So so this RS upon 5 equals to 5 upon 13.
But RS is okay. You went for solving RS, was it?
Yeah.
No, I want you to stick with PS itself and explain.
Oh, sorry, sir. Oh, PS. Okay. So in that PS is the medium side, and so it's R upon 5 equals to 12
Or
upon 5.
H upon 5. Okay, H upon 5, right?
Yeah. Equals to 12 upon 5.
Okay. There's a lot of noise, Akrit. I don't know why it's on your side. Can you unmute for a second, Akrit?
So I'm unmuted.
Sorry, can you mute? I mean, yeah. So lot of noise. Were others also able to hear a lot of noise? Or yeah,
Yes,
Akshay
sir.
just okay.
So there was a lot of disturbance.
Lot of disturbance, right? Okay. So one more time, Neve. Okay, so I'll just explain one more way, right? So this is the I'm comparing the smallest triangle. What you said was perfect, Akrit. I'm just explaining it once more for Neve and anyone else who's still not completely got this. Yeah.
So I actually did it the same way. I just I didn't like I did it both the ways, like with area and similarity. So I
Okay, great. Cool.
I
All right.
did it.
So just for completeness, I'll just do it one more time. I'm comparing the smallest triangle and the largest triangle. And then let's say I'm comparing medium side versus the largest side. Okay. So I have a grid here, right? So smallest triangle. Okay. Just a little clumsy here. So smallest triangle and the largest triangle. And then I'm comparing medium side and the largest side. This is the medium side and the largest side. So this is sides. Okay, so medium side is H here, and the largest side here is 5 in the smallest triangle. Correspondingly, in the largest triangle, medium side is 12, and the largest side is 13. That's it. You equate these two. Okay, cool. So we all agree PS is 30 by 13. Let's move fast. Akshaj, QS. Answer batao.
So QS will be
In fractions.
44 by 144 by 13.
I'm writing your answer as it is. Approximately 144 by 13 is how much in decimals?
Around 11 point.
Exactly. Around and does this look around 11.1?
Yeah.
It does look. And yes, indeed, it's 144 by 13. Did anyone not get 144 by 13? Ashi, you got 144 by 13 as well?
Solve it this way. I didn't solve it this way. I just directly.
Sorry, so Arnav, you're saying something?
Yes, so I didn't solve this way, like getting QS and everything. I just directly went and I got 60 by 13, doing R upon 5 equals to 12 by 13.
R upon 5 R is what? What is R?
Like H, okay, H. Like
Ha.
took it as R.
Yeah. So which and which you're comparing the small triangle with the medium triangle, correct?
Small with the big.
Small with the big. But in the big triangle, QS won't even be part of the big triangle. I'm
Yeah,
looking at.
exactly. So I didn't find all of that. I
So how did you arrive at 144 by 13? Arnav, can you explain
No,
once
I
more
didn't
then?
get 144 by 13. I just directly gave the answer 60 by 13.
60 by 13 is PS. Now we are done with PS. So we are done with PS. We are moving on to QS. So for QS, Akshat said it's 144 by 13. Then I asked, did anyone not get 144 by 13? And Arnav, what are you saying? You did not get 144 by 13.
No, I didn't solve. I thought we only had to solve for PS.
Oh, no. We wanted to solve all four. We
Okay.
started discussing one after the other. We are done with the PS discussion. We are moving on to the QS discussion. So isko 144 by 13 mil gaya tha. Have you got 145 by 13 as well, Arnav?
So I didn't solve for it. So let me
Okay.
just see.
All right. Can you do it, please? Yes. And similarly, SR also. I'll wait. I'll give another minute for you guys to finish QS and SR, whoever has not finished. Meanwhile, Snigdha, have you finished SR? If so, can you call out the answer for SR?
No, sir, 2 minutes.
Okay. Jan, have you finished?
Sir, I'm solving.
Okay. Arnav, you can lower your hand. I don't know, your hand is still up. Anyone has got SR?
Yes, I got SR.
As what?
So I got it as 25 by 13.
25 by 13. And does it pass the sanity check? 25 by 13 is approximately how much?
Or a little less than 2.
Okay, does this look like 2 approximately in this diagram, in this context? It does. Compared to 5, it looks a little smaller than half. So yes, indeed, it's 25 by 13. It's correct. So all 4 answers that are finally written down are correct. If anyone has not got anything, I can wait and explain. And one more way, guys, just watch here. QS plus SR, if I add up, I should get the original 13. Do I get that? If I add these two numbers, I get 144 plus 25, which is 169 upon 13, which is 13 because 169 is 13 square. So that extra sanity check also passes. Collectively, they should add up to 13 together. Right? Does it make sense? Ashi, you're okay with this one?
Yes, sir. I got that both of them are added, but I'm a little confused with how SR is 25 by 13.
Okay. Did you get QSS 144 by 13? You're okay with that one?
So somewhat it's the other side, and then you do 1 minute.
Okay. All right. I will explain both QS and SR once more. Okay. Or try it for 1 more minute, guys, and then I'll explain both QS and SR. It's the same concept. You need to go through 3 times and then you'll be fine.
Sure, I got it.
You got it? Okay, good.
Sir, I got it.
Got it, Ashi? Okay, cool. All of you got it? If all of you got it, then I don't need to go through again. Or maybe I'll go through SR alone once. Okay. So SR is where SR appears in the smallest triangle and is the smallest side. So I'll focus on, I'll erase this here. So I'll compare in the largest triangle, everything is known. So I can always use that. And in the smallest triangle, so in the smallest triangle, SR is the smallest side. So I'll just use smallest side. Okay. And in the smallest triangle, do I know any one side? I know the largest side. I can use that. Largest side I know. So I will write out. So the smallest side is SR, which is what I'm trying to calculate. And the largest side I know is 5. And in the big triangle, right, the big triangle, largest triangle, 5 is the smallest side and 13 is the largest side. So now, if I write this equal to this, by cross multiplication, I get SR is 25 by 13. Make sense? Saurabh, you're with me completely on this? Pakana?
Yes.
Okay,
Yeah.
cool. All right. So we did quite a bit on this one. Let's see, similarity. And all of you know all the congruency rules, right? So
We did it last class.
last class, right? All the SSS, SAS, ASA, and ASA is same as AAS, right? Which is the congruency that's not, or rather, which is the test which is not to be used for congruency? Which one? Say that again, Ashi.
ASS.
Is for similarity, ASS is not possible.
Correct. Both of you are right. So answered two different ways to the same question. Yes, ASS is not used for congruency. Okay, this is congruency. So congruency tests are these few: SSS, SAS, ASA, which is equivalent to AAS, right? Because it's, if two angles are given, the third angle is already given, right? Because it's third angle is inferred rather. So I can call it as A. Okay, I'll just say this is ASA, and the third angle is also given effectively. So it becomes same as AAS, right? Which is same as AAS. Are you guys with me? If two angles and an included side is given, doesn't matter. If two angles are given, it's effectively like all the three angles are given. So effectively, it's all ASA or AAS are all same things only, right? I like to bucket these two and as one category. ASA and AAS are effectively same. You can, some people also call it AASA because the side effectively is included between two angles and the third angle is also same. So all three are same. Okay. Now there's one more which is also valid, which is RHS. Saurabh, do you know what RHS is?
The right hand side.
Right hand side. That's the correct one acronym. But in this context, RHS is not right hand side. It's used for congruency. What is it? Yeah, Arnav.
So right hypotenuse side.
Exactly. In a right angle triangle, so that's the first right. So you are right in that right, to use the word again in multiple ways, right? Another right. Oh my God. Okay. So this is right. Okay. And this is hypotenuse, not hand, but hypotenuse. And this is side. So if I have a right angle triangle like this, I have another right angle triangle like this. Okay, very ugly. Let me just draw it once more. If I don't use the scale, it becomes very messy. But every time to toggle between the scale, it's also a pain. Okay, so if I have this right angle triangle and this right angle triangle, now if I'm given that, first of all, I'm given both are right angle. That's first, R. Okay, now I'm given the hypotenuse and the two right angle triangles are matching. So this side is matching with this side. And I'm saying one side matches one side here. So let's say this side matches this side here. So in a way, this is like ASS, because one angle is given, one side is given and another side is given, and the angle which is given to be matching is not the included angle, right? So in a way, it's ASS. Do you agree? It's in a way, it's ASS. All of you, Anif, do you agree with me? It's ASS.
So why can't it be
Yeah.
Why can't it be?
SAS?
It cannot. The way the property is defined here is right angle, hypotenuse, and the side, which is what I've marked, right? I've marked a right angle, I've marked the hypotenuse, I've marked another side. You tell me, is the angle included between the two sides that are given to be equal?
Wait, no, it's not.
No, right? And therefore, it is not ASA, or rather, it's not SAS, it is ASS. But we know that ASS does not work. So the answer is not that ASS does not work. ASS works under certain conditions, right? What those certain conditions we'll study later. But in general, it cannot be used for a test. For a right angle, it can be used, but not just right angle. There are other cases also where ASS can be used. But what those are, we'll skip for a later. For now, I want you to acknowledge two things. That this is also ASS in a way. RHS is like ASS, but a special ASS. And therefore, it works. It's a special ass. Okay. So the special donkey works, not a normal donkey. Yeah. So RHS works. And why does RHS works? Let's say this length is given to be, I don't know, 8 centimeters. This is given as 8 centimeters. And this is given to be 3 centimeters. This is given to be 3 centimeters. Then by Pythagoras theorem, I can figure out this is 64 minus 9, which is root of 55. And I can do the same thing. I arrive at the same calculation. Now the two triangles become congruent by SSS property, or back to what Ashi was telling, SAS also, because I have 3 sides, I have 1 angle also. Now I'm very wealthy. I can use whatever I want. Everything is at my disposal, right? So effectively, these two triangles become congruent. But I could do this root of 55 only because it was a right angle triangle. I could do square root of 64 minus 9. In a normal triangle, I cannot do that, right? Which is why it's not a acceptable congruency property. Okay, again, I say that with a caveat. Even in non-right angle triangles, there are cases where you can use ASS. But I don't want to over confuse you right now. For now, just stick with that ASS cannot be used. I'll pause here for a second. All of you okay on this? Stigda, why am I not seeing you for a while? Why is your video off?
Sorry.
Sorry, sir, as in you're going to be turning it on? Okay, good. So yeah, please guys, leave your video on throughout the class. I like to read from your faces throughout the class. Okay, any doubts guys so far? All okay? Rachit, you're okay? Soram? Okay, all right. So let's shift gears a little bit. And I think we started doing this permutation combination towards the end of last class, right? Did we? So, did we or did we not?
No, sir, we didn't.
No, we did not? Okay,
We
all
did.
right. We did? I remember doing it. Okay. Again, a couple of 2 batches, right? So
First
sometimes I
class,
get...
sir, in the first class, you did a bit of it with us.
Not in the very first class. In the previous class, did we do something towards the end? No?
No, sir.
No,
Okay.
sir.
Okay. No, that's fine. Sorry. Since I have 2 batches, I get confused. What more or less over time will be the same concepts covered in both, but thoda aage piche rehta hai, so which is why I'm little not sure. Okay. So 2 things, right? These are so choosing, arranging, they are concepts. Okay. So mathematics, the buzzword that's used is combination, because choosing seems very, very dull and naive, right? So you want to use very hi-fi words. Combination, and this is called permutation, so that it looks hi-fi, right? By effectively arranging, right? Arranging is same as permutation, choosing is same as combination. So together, these are called as permutation and combination, which is PNC. So when people say I studied PNC, that means permutation and combination, which is arranging and choosing. Okay, so first let's study the choosing business. So choosing matlab kya? So suppose, let's say I have a bag or a library of several books. Let's say, I don't know, English, maths, physics, chemistry, bio, some other subject guys, history. Okay, one more in a different letter. Geography. Thank you. One more, please.
Computers.
Which one?
Computers.
Computers is C, no? I've used C for chemistry. Something else.
French.
Science, physics, chemistry. Okay, ठीक है.
The French.
French. Okay, fine. French. Okay, all right. So how many other? 7. There are 7 books in my library, but my small little bag can accommodate 3 books. Okay, I can put 3 books in my bag. That's it. Okay, and I've intentionally drawn the bag a little weird because I'm just going to dump all the 3 books. I'm not a very organized person. So there's no question of arranging here. I'm just going to pick 3 books and put them all in this. So for example, I could end up picking maths, which is obviously my favorite. I can pick maybe history and maybe chemistry, right? So this could be one way in which I could pick my 3 books. Okay, now Akshaj might pick some other 3 books. Snigdha might pick some other 3 books. The question is, how many different ways can we pack our bag with 3 books? How many different ways are there in which I can choose 3 from this 8? Okay, that's the question. Yeah, Akrit, go ahead, please.
35.
35. Okay. Okay. All of you think, and then we'll discuss.
So, so that matter if like which book is first. So like,
No,
if
that's why I said my bag is very cluttered. There's no partition saying this is the first book. I'm going to dump 3 books. That's all. There's no arranging there.
then 35.
Okay. Akshaj, your hand is up.
56.
56. Okay. Any other answers?
So 343.
343. Okay. Remember, I have only 1 book of each. So I cannot put math, and math. Although I love the subject a lot, there's only 1 math book. So I cannot have a bag like this. There's only 1 math book.
Oh, then I'd like to change, please.
You better. Which is why I said this, right? I knew you got your 343 by doing. Not you. Saurabh, what is 343? What does it ring a bell to you, Saurabh?
So I think 7 cube.
7 cube. Yeah.
So I think 210 then.
210. Okay. So I'm erasing your 343. I'm putting 210. Okay. I'll wait 30 more seconds and then we'll discuss answers.
Then I got 56.
Okay. Another 56 as well. Who was that? Jan.
Me.
All right. Okay. Akshaj, explain your 56.
So the formula for combination is.
I don't want any formula.
Oh,
Just
okay.
go with basics. Just explain to me basics.
So I use the formula.
Fine. Okay. Tell me using the formula.
So the formula is n factorial over r factorial into n minus r the whole factorial.
Okay.
So
And how many books are there here? There are 8 books here, right?
yeah, so 8
8 or something.
factorial over 3 factorial into 5 factorial.
Okay.
So it becomes 8 into 7 into 6 upon 6. So 8 into 7 becomes 56.
Okay. And Akrit, did you make a mistake of assuming there are 7 books here instead of 8? You said 35, right?
So there were 7 books, right?
Yeah, I too thought I had written 7 books, but I counted now as well.
You said 7.
Looks
So
like there are.
I thought
Yeah,
I was
when I saw your
7.
35.
yeah, so you said 7.
Yeah, maybe I said 7 books, but I wrote 8 books. So based on the diagram, 56 is right. Based on what I said by mistake as 7 books, you are right. It's 35. So if you do 7, choose 3. Okay, for people who don't know, don't worry about it. We'll cover it, right? So yes, you are right, Akshaj. But I want you to know what is this? Why are we getting this formula? That's
So
important.
what do you mean by factorial?
Okay, I'll tell all of this. But first, Akshaj, do you know how this comes? That's important. Akshaj?
Yes, sir.
Okay. You know this formula, which is wonderful. But do you know how it's coming from?
So is it because we're trying to find how many ways to remove the same number of books? Or that will become permutation? No.
Okay, not exactly.
Yeah.
Okay, fine. Akshaj, can you explain? Assuming it's 8 itself. Let's not assume it's 7. Okay. Oh, oh my God! Why is there so much echo? Akrit, something wrong on your side only, I think. Okay. Back to Saurabh. Someone was asking what is factorial. Factorial is nothing. If you put an exclamation sign to the right of this, it means you start with that number, multiply all the way till 1. That's called factorial for short. Yeah. So 5 factorial is 5 into 4 into 3 into 2 into 1, which works out to 120. So you'll see in permutation combination, these factorials very often you have to multiply all the way till 1. So rather than write it out elaborately every single time, you just quickly put 5 factorial. Okay. Yeah, Akrit, go ahead, please.
So in 8 choose 3, like you can imagine like 3 dashes. So for which books you could put in. So you can put in like, suppose you want to put in English. So for the first book, you have 8 choices. For the second, you have 7 choices because 1 is already taken. And for the third one, you have 6 choices. But as also the thing that it doesn't matter if you take like history first or if you take math first. So like history, math, and then computers. What is C?
Yeah,
History,
let's say
math, and
chemistry. Yeah, okay,
computers.
yeah. Mhm.
And chemistry, math, and history are the same combination. So like how many ways are there to arrange it? That would be 3 into 2 into 1. So you have to divide it by 6. So there's no double counting. Like
Excellent. Very well explained. I'll go over it again once more for class. Okay. So right. So first, let's think about, suppose my bag actually had like partitions like this, right? So the 3 books, right?
Then it would be 336.
Then it would be whatever, 8 into 7 into 6 without the dividing by 6. Correct. So suppose I have my slots like this in my bag, then I would say any one of the 8 books can land up here. Any one of the 7 books can land up in the second slot. Any one of the remaining 6 can land up in the third slot, because I've labeled my bag as, this is my front of the bag, this is my center of the bag, and this is my back of my bag. So because of that very arranged type of thing, right, it's 8 into 7 into 6. But now what Arnav is, Akrit was telling is, my bag is not a very arranged bag. It's just a collection, right? The arrangement, there's no concept of arrangement, which means whether my books are placed as MHC or HCM or CHM and a few more like this, they're all actually the same combination only. I'm only interested in choosing. I'm not worried about arranging them, because there's no concept of arrangement. And therefore, this 8 into 7 into 6 is going to have a lot of double counting, because like I said, right, all of these are to be treated as one, but I'm counting them as many. How many? For each set of triplet, for each M, H, and C, in how many ways can I arrange them? For example, let's say M, H, and C are already chosen. In how many ways can I arrange them? I can call any one of the 3 to occupy the first spot, any one of the remaining 2 for the second spot, and naturally the last one has to be the third spot. So there are 6 ways, if in fact I have to write out all of them in alphabetical order if I start writing. So let's erase this. So C comes first, then H, then M, right? So let's write it as they appear in dictionary. So CHM, CMH, then HCM, HMC, and then MCH, MHC. So these are the 6 ways in which I can arrange them. And actually speaking, they're all the same set of 3 books if I'm just interested in choosing them. Therefore, to avoid the excess counting, I divide by 6 and compensate. So that's how I get 56. Is this clear how I arrive at 56? Okay. So, Jan, you wanted to say something?
Yes, so I actually used a different method, like a different formula.
Go ahead, Jan. What is the formula that you
So
used?
I used the formula n into n minus 1.
N into n minus 1?
Yes, sir.
N into n, go ahead, please. N into n minus 1. Why n into n minus 1?
So, I remember using this formula in IPM for like combination sums.
Just n into n minus 1. For
So like n is the total number of like the total number of things. For example, books here. So n, so there's 8 books, and then 8 into 8 minus 1, which is 8 into 7, which is 50.
In this case, you were just lucky that the 6 cancelled. Suppose instead of 8 books, suppose I had 10 books to choose from. Then your answer would have been 10 into 9 into 8 by 6. That would have been the correct answer. Whereas you would have said it's 10 into 9, which would have been the wrong answer. In this case, it so happened that the third one matched with the 6 that was cancelling out. Okay. Does it make sense, Jan? Yeah, Jan? Yeah. My request to everyone is, don't use any formula unless you understand it. Okay. I mean, I wouldn't say don't use any formula. Some of the things you'll have to take it for granted, and later you will see for yourself why it works out. But these are all very basic things where you can actually see why it works, right? So let's, okay. So you saw how it worked as 8 into 7 into 6 by 3 into 2 into 1, right? So you're okay on that one? 8 into 7 into 6 by 3 into 2 into 1. So this, in fact, that's exact. I'm not even going to cancel this 3 into 2 into 1. I will just write it as 8 into 7 into 6 by 3 into 2 into 1. I'm not going to cancel it. I'll just write it like this. So this is what is called as 8 choose 3. So people write it as like this. Sometimes people write it like this. Brackets like
Why
this.
did you stop at 6?
Because I only
intermediate 3 box.
I only needed to select 3. Therefore, I stop after reaching 3 counts: 8, 7, 6.
So if it was, you could choose 4.
Yeah.
Then
So
it
for
would have gone 8,
example,
7.
from 10 books, suppose I have to select 4 books, it will be 10 into 9 into 8 into 7 upon 4 into 3 into 2 into 1, because that's the number of ways in which I can arrange them. That will be the excess counting. Does it make sense? Okay, so this is of 8, I'm choosing 3. Therefore, it's called 8 choose 3 like this. Okay, now the reason the factorial is brought into the picture is because suppose I'll have to write 128 choose. Let's say I have 128 books and I'll have to choose, I don't know, let's say, give me some number, guys, 25 books, right? It becomes a pain. I have to write 128 into 127, and then I have to figure out what will be the last entry here, right? 128 into 127. Can you tell me, actually, what will be the last number here? Here it's 25 to 24 all the way till 1. What will be the last number here? Yeah, Akshaj?
123.
123.
Sorry,
125.
103.
103. Thank you for the correct wrong answer, meaning that was the expected wrong answer. It's 104. Okay. Always when counting, right, it's the difference plus 1. If I need 25 elements, the difference between this and this needs to be 24. You can see that for small numbers, from 25 to 1, it's 25 numbers, right? What is the difference between 25 and 1? It's 24. Right? So when I'm counting numbers, if I need 25 count, then the largest and the smallest must be apart by 24, one less. Make sense? Thanks for making that mistake. It's a very common mistake. So all the way till 104. But the point is, you have to think a lot and put all the way till here. It's clumsy, right? So how do I write this more efficiently? The bottom is fine. I can still write it as 25 factorial. But the upper wala is a pain. I still have to write 128 into 127 all the way till 104, or show with dot, dot, dot like this, which is all a pain. So people said, let's try to make it easier by, okay, I'll write it towards the left here, a little bit here. So 128 into 127, and the chain continued all the way till 105 into 104, and this was 25 numbers, and the bottom was 25 into 24 all the way till 1, which is 25 factorial. But because this upper wala was clumsy to write, people said, let's continue this by multiplying and dividing by some number. What number? Suppose I put 103 into 102 all the way till 1, 103 into 102 all the way till 1, both in the numerator and denominator. Then this whole collection, first of all, I've not changed the value because I've multiplied and divided by the same quantity. Now the upper wala just becomes 128 factorial. And the bottom wala I have multiplied by 103 factorial. Does it make sense, guys? Ashi, you're with me?
Yes.
Okay. All of you with me, right? Okay. Therefore,
Yeah.
generalizing this, I can, suppose I have n objects, I'll change color. Suppose I have n objects or in my library, or n books, whatever. I have to pack my bag using r objects or books. The number of ways in which I can choose them is n factorial upon r factorial into n minus r factorial, for this reason that we just saw. Akshay, this is clear now, why we're getting the formula from.
Yes.
Okay. So in the first example, it was just, which is what he used. He said 8 factorial upon 3 factorial into 5 factorial. Of course, 5 factorial was equivalent to this big one, right? This entire 103 factorial is like your 5 factorial. So he was only worried about the main numbers, 876 upon 321. Right? Does it make sense? Okay. All right. Let's stop here with that. And then we'll pick up this next week. Okay? Sounds good. See you next week.
Oh, thank you, sir. Bye, sir.
Bye, sir. Thank you.